All right, sounds good. So welcome everybody. Just a little bit more about myself: husband, father, entrepreneur, retired. Um, but I still do adjunct professor for a local college up here in Pennsylvania, or out here in Pennsylvania. I don't know where everybody's from. So, but I do a adjunct professor for a home inspection course as well. But I have a lot of experience, 40 plus years in home construction, remodeling. I actually just got finished doing a big job on my own house, so I still do some work. I try to taper off from that. 22 years in customer service management and engineering. It was actually for wireless systems engineering and project implementation, and 15 plus years in the real estate inspection and continuing education training. Um, just a little quick little story how I got involved with Stucco is met several years ago when I was doing I was going through the training process for Pennsylvania, and one of the requirements was I had to do, I think it was 100 inspections with a certified inspector. And so I connected with several different inspectors just to get through it a little bit faster. And one of those inspectors happened to do stucco inspections. Now, the stucco inspections didn't count for the state's requirements because they weren't home inspections, but I got to learn a lot from the stucco inspections. I really enjoyed it, and it can be very lucrative. At the time, home inspections were typically in the $350 to $400 range. A stucco inspection can actually, they start at 600, $595 was the cheapest. That was just for a single wall inspection. And if it was an entire house, they started at $895. So it can be very lucrative if anyone's interested in getting into the stucco side of it. And there's not nearly as much competition. Now, again, if you're in Pennsylvania, there's a lot of houses with stucco. So it was fairly, lucrative in that sense. Is a lot of my inspections were specifically stucco inspections. But that's how I got involved with stucco inspections, just because it was part of the training process, and I ended up learning a lot from the inspectors that I worked with. So, well, we'll get into it now. So, so stucco is misconceived. Stucco is not a bad product, and that's where it gets a bad rap because everyone says, "Oh my gosh, it's stucco home! Oh my gosh, run, stay away from it." And that's not really what the issues are. The issues aren't because of the stucco. The issues are because of the lack of flashings, lack of maintenance, lack of detail. For instance, like vinyl siding is one of the most forgiven sidings, and stucco's the least forgiven. Water's going to get behind every type of siding if it's not flashed or caulked and sealed properly. It's just that vinyl siding, the water just runs through, runs in behind it, and it runs out the bottom, and the wall dries out. Well, stucco and other materials, it doesn't just do that. It gets trapped inside there, and then that moisture is the problem. And it's not because of the stucco, it's because of the lack of flashings and other details that created the problem. So, like I said, it just gets a bad rap from that standpoint, and then rightfully so. Some of the reasons I want to go over some of the reasons why this occurred as well is in the mid '80s, EIFS, exterior insulation finishing system, was introduced into the U.S. It was a European product. Dryvit was the main manufacturer at that time. Um, but there was a big housing boom in the '80s that was occurring as well. And at the same time, the types of materials were changing. And with that housing boom, there was a lack of skilled stucco contractors. So whoever was walking down the street at the time, they became the stucco contractor. They're like, "Hey, you're my stucco contractor," because I don't know, they may have had a trowel in their hand at the time. Um, But the building materials changed as well. We're going to cover a lot of that. Different materials, such as like they used to use planking underneath, and then it switched to a plywood, which can both can withstand some type of moisture. And then it was replaced with OSB and a lot of other materials. And OSB does not withstand the moisture like a lot of these other materials. So there was a lot of problems, excuse me, there was a lot of issues and problems occurring and a lot of changing going on. And then in the late 90s, they realized the problems with EIFS was water was getting behind it and getting trapped in there and rotting the wood out. Well, that also occurred with stucco. I'm sorry, let me just go back one step here. In Europe, the majority of the houses, the construction is a masonry constructed house, and then they put these products over top on the exterior. Well, in the U.S., the primary construction of a house is wood, two by and framing and so on. So there was a lot of things that were changing and that occurred during that time period that really expanded, compounded why there was a problem with stucco. So we're going to cover the basic characteristics of stucco homes, identify common problems associated with it, and explain what to look for as a stucco inspector, or what the home inspector looks for when inspecting stucco. So as a home inspector, if you come across a stucco, because I belong to a couple different, groups, messaging and different things. And a lot of times it'll be asked, oh, this stucco has this crack and that crack and that. The bottom line is, or my recommendation is, if there's a stucco house, recommend a stucco inspection to be performed. If you don't do one yourself, recommend it and hire a stucco inspector, because most of the time problems are going to be found and identified. And we're going to cover a lot of that tonight, hopefully. Oops. So just a little fun quote that I like is, just don't go to work, create excellence, so it's just, one of those quotes that I like. I have a couple quotes throughout here. So many states don't require certification for stucco inspections, but they do require certification for EIFS inspections. Like I said, exterior insulation finish systems. I think it's a good idea to have the certification, because you can just, it puts yourself at a higher standard. You can promote that you have the certifications. And, InterNACHI provides that training as well, which they provide a lot of other training. But these other two companies are also other means to get that training. Exterior Design Institute, very well known, a very intense training program, and then Moisture Free Warranty has a program as well. So the questions, you can always ask questions at any time throughout these slides. We will go through them, we'll answer any questions. I use these slides as kind of breakpoints for my talking as well. So we'll keep going. But part one, we're going to cover basic wall construction, stucco construction, and protective flashings that I just discussed about houses having a lot of lack of protective flashings. So the basic construction of a house, here's a typical framing structure. You have your wood framing, your headers, and all the wood framing and everything going on. Oops, I forgot to take something off of there. And then here's just another look. You have your plates on the top, your king studs, your trimmer studs. They all hold everything together. Different headers, your window headers, your door headers, and so on. And then you have your bottom triple studs and so on. And this is just to get an idea of where and why to test certain areas for moisture with stucco inspections. So like I said, the wall sheathing types changed during that time period. And here's just different types of wall sheathing that at one time they used to be used 1x6, 1x10, 1x8, different types of pine wood planks. Now I'm going back, it's a much older house. and then it switched to plywood for the exterior sheathing. And even plywood it's called CDX. Is what they do. C and D are the finish on the each side of the plywood. The X is for exterior grade glue that was used for different types of, typical plywood, and it could withstand a certain amount of moisture before it had problems. It will rot still, but it could get wet and dry a few times before you had that problem. Then they came out with OSB, oriented strand board, which is a flake board type material or particle board, and it cannot withstand moisture at all. Even the littlest bit of moisture can create problems with OSB. And then they also came out with this rigid foam board, which did not last. It did not do well. It was almost like a denser cardboard like type material. They have fiberboard came out, didn't do well either. And they even had several houses. They use some of these in specifically commercial, but they came out with a gypsum board, and yeah, and it's like a more dense type of drywall was used for the exterior sheathing, and that did not fare very well either. Um, so I have pictures of all these different types of material. So here's your typical OSB and plywood, and OSB is the most common that you'll see out there. And then some have like a foam board type sheathing as well, which I'll show you some of those. But OSB is the type. It's the most commonly used on houses in our area and many other areas. And it just, like I said, it just does not withstand moisture very well. So there's a lot of issues there. Um, and then they have this is the foam type of foam board insulation, and then they have the fiber board, which are these two over here. These are actually fiberboard drop ceiling panels, but it's a fiberboard material. So and then here's some siding. This is the gypsum board shown in this picture here, and here's some more gypsum board. And it was just like drywall, but it was exterior grade drywall. It didn't do very well. Here's some OSB showing typical. The bottom corners of windows are the most susceptible to problems. We'll cover that, and you can see here a lot of staining and discoloration of the material here. Usually, it's a sign of rot. And then also, the other I talked about the material changing, the actual windows themselves were changing during that time period too. They went from a solid wood constructed window to then they came out with vinyl clad. They had aluminum clad for a little bit there, and then they came out with a solid vinyl window. So there's a lot of changing of materials that created a lot of these problems as well. So here's a couple houses. This is a house with plywood. Here's a house being done with the OSB material, which is very common, very typical. You see, here's a house with the pink foam board insulation that's very common. And in these types of houses, sometimes the corners will be plywood, or sometimes they'll have diagonal bracing underneath of this foam board, so it keeps the framing structure wrapped properly. And then this is this fiberboard material, which it didn't last very long. It wasn't used that widely because it just had a lot of other issues with it. But that's what it looked like if you happen to ever come across that. So then they also came out with so the moisture barrier types is a key part of this as well. And that changed also during that same time period. They used to use what was called 15-pound felt, and it was 15 pounds per square, which is 100 square feet. And it was pretty thick material. Well, they changed it and called it number 15 felt, and it was a much thinner product, so it didn't withstand it as well. It didn't have the problems, it didn't have, it just didn't do so well especially with stucco. So what was happening was the 15-pound felt or the number 15 felt was the most commonly used at the time, when the stucco was coming about. And as stucco was applied over top of it, the stucco would stick to it. And because stucco is a cement-based product, as it cured, it shrunk. Well, it would shrink and it would tear the felt paper. So that creating gaps in your moisture barrier, is a significant part of the problem as well. So to resolve that over the years, you either need to do a double layer, so it was a sacrificial layer of the 15 felt, or they came out with a lot of different products and different types of house wraps that were specifically designed for the use with stucco. And they had ridges in them and they had drainage planes. They had a lot of different products out there. So just knowing what is behind the wall has a great effect on the probability of having problems. So just that's part of it, is identifying what is there. And unfortunately, it's a difficult task because you can't see through finished, the finished material to figure out what's behind everything all the time. Oops. Sure. So here's a house here. This is your typical felt paper wrap. That one looks like it might have some, that's just a felt paper wrap. So I had to look a little closer. And then your Tyvek material, which was one of the first house wraps out there. There's a lot of different brands nowadays. That type of wrap came out originally. Tyvek was a manufacturer. Here, here's just showing that felt paper again, not more felt paper. Like I said, it was very commonly used. So I thought I fixed all these. And then here's the foam board didn't always require different. So that's just a different type of house wrap. It's just a different manufacturer, so it's a different color. There's the Tyvek one as well. You have to ignore some of these. I thought I got all those off of there. I must have missed a couple of them. And then we also have, again, here's the Jumbo Tech. Now, this material was designed after the fact of all the problems, and it was specifically designed for the use for stucco houses because it had a drainage plane built into the actual material. It had these like bubbles, which are they're hard to see. This is actually a wire mesh over top of the Jumbo Tech. Not the most common wire mesh. That's not typically what's used for stucco, but that is a type of wire mesh. But anyhow, the Jumbo Tech has bubbles and it moves, it separates it, it creates air gaps, which is always good, and a drainage plane. So not if moisture gets behind, but when moisture gets behind, it has a way for it to drain out, trickle out, and come out the bottom. As long as the material itself is applied properly. So again, any questions at all, please post anything, or you can send follow-up questions after you guys have time to review these slides a little bit. I'll be more than happy to answer. We'll give you my email contact information at the end. So from a stucco standpoint, there's two primary types. There's a typical traditional hard coat system, and then there's the EIFS system, exterior insulation finish system. We're going to primarily focus on traditional hard coat, but everything I talk about applies to the EIFS as well. So we're going to kind of cover both. Now, in the traditional hard coat, it's typically a 3-coat application. They do have a single and a 2-coat application, but the 3-coat application is the most widely used. We'll cover that. I think I have one other slide on EIFS, and then after that, we don't even talk about EIFS anymore. So on a traditional hard coat, so you have your framing structure and the sheathing, which it could be any of those items that I mentioned, plywood, OSB, today. And then it has the moisture barrier drainage plane, which is required in houses being constructed today. It wasn't required on older houses. The requirement probably came in the mid 2000s range, is when they started really, coming out with a lot of requirements. And then they put a wire lath over top of the moisture barrier, and that's what really, that being, fixed to the house with either some type of a nailing system, or they have the nails with the big plates on them and so on. That's what really holds the stucco to the house. And then they do a scratch coat. They have to let that dry, and then they put a brown coat on top of that, and that has to completely cure and dry before they put the finished product on there. Now, the finished product could be stucco, which is what we're going to cover, but also synthetic stone, aka also known as lick and stick, is another product, and the what's behind it is the same as stucco, so the same rules apply. Everything just view it as the same and say, hey, it's just another stucco finish. It's just a different type of finished product over top of the stucco wall. Um, here's some. This is the scratch coat being applied right here. Again, this one's over top of a stone or brick foundation or wall. Same process. They put the wire mesh. This is typical wire mesh that should be behind the stucco, like this. Now today, currently, these look like they're just nails or screws being used. Today they have to use those. They're like 1 inch by 1 inch square plate with the nail or screw in it, and they have to be placed every so many feet. So there are a lot more requirements on how the process is done today. And then the synthetic stone, which I talked about, it could be a lot of different varieties. It can be this type, that then you do a little mortar between it. It can be a dry stack. But the lick and stick really comes from this process here, is after you have your brown coat and it's all, cured and ready, they really just put a smearing of another type of, thin set mortar on there, and they just squish the stone right over top of it, and it sticks to the brown coat. So it's just a different type of finish instead of stucco. Stucco could be the finish, or it could be one of these types of finishes. The walls still are the same way. Again, this is different layer and has showing the different layers. The gypsum, or that's the inside, the bat, the wood framing, the exterior grade sheathing, whatever it might be. This says 2 layers of weather resistor barrier. 2 layers is not required if you use the weather resistant barrier that's designed for stucco. But otherwise, 2 layers is required. For that reason, like I said, they need that sacrificial layer. And then the last, and then you have your brown coat, scratch coat, brown coat, and then your finishing system. It could be either that stone, it could be a stucco material, and then your different flashings. We'll get into some of the flashings in a little bit. So over 90% of the stucco homes, now when I say in our area, I'm meaning in Pennsylvania, are traditional hard coat material. And the typical application is supposed to be 3/8 of an inch thick. And that's very rare to find 3/4 of an inch thick. 7/8 is optimal, but I haven't rare, but it's very rare to find one that meets those requirements. 1/2 inch is pretty normal, it's standard. And what happens is it's not leaking because of the thickness of the stucco. Now, there may be more cracking occurring, but unless it's exaggerated with cracks, moisture's not getting. Now, a certain percentage of moisture gets through the stucco because it is a porous material, but that's minimal and compared to a flashing detail not done correctly. And another problem they came across is these, as stucco houses were being built, they were being sold and promoted as maintenance free. Nothing is maintenance free. They require cleaning, caulking, minor repairs, because everything has to be sealed properly, especially caulking. Caulking doesn't last forever. So if it's not flashed properly, caulking is a means of flashing, not a good means, but a means. And that requires, some a periodic maintenance as well. At least, maybe twice a year to at least check it out and replace it as needed. So here's that one other. Oh, there might be another. I talked about the EIFS. EIFS is very similar in the sense that you still have the framing and the substrate. You still have a moisture barrier. Now, however, instead of the wire lath over top of the moisture barrier, and this is just for ease, they actually use an insulation board. It's typically an inch and a half to 2 inches thick, and it used to get glued on to the house. Um, Currently today they actually glue it and secure it on with some type of wall anchors. And then there's a fiberglass mesh that goes over top of that, which you can see here, and then they put a base coat and a finish coat. It's a much thinner finish. Traditional stucco, 3/4 of an inch, half inch, 3/4 of an inch. Typical EIFS, it could possibly be a 1/4 inch or even less. A 1/4 inch would be really thick from an EIFS standpoint. And usually the EIFS product, you could press it with your thumb and it feels spongy. You should be able to push it in, push it out. That's how it's an easy way to say, hey, this is an EIFS house, not the traditional stucco. Um, Here's a couple applications of the EIFS. You can see this is that styrofoam that gets adhered to the house first. Here's a cutaway. They're actually looking behind it because the corners of windows leak. They do. They do. And a lot of times it could be the window, or it could be lack of flashing or lack of maintenance. So even the way window details get flashed is significantly different today than it was, 10 years ago. As a matter of fact, just a quick story is I'm in the process of replacing all my windows on the house here, and actually I just finished it. But some of the windows, now my house is 25 years old, so it's not that old, 1999, and so what I was finding was, now we have vinyl siding with vinyl windows, that some of the windows, moisture was getting in the corners of the windows. Now, it could have been getting in the top, but it was getting to those corners, and there was a lot of rot and deterioration occurring. So I had to fix all that first and then do the flashing detail, which I think there's a slide on that. It talks about the window. You have to, create a window pan flashing, and then the way that the sides are all done has changed over the years as well. So we'll get into that in a little bit also. But back to the EIFS, that's what it looks like. Now, like I said, typically a 1/4 to 3/8 of an inch thick, and 3/8 of an inch would be really thick for an EIFS product. 1/4 inch is even pretty thick. It's usually a little thinner than that. And in our area, again, Pennsylvania, it's more common on commercial buildings. Some townhouse and condo developments still use this EIFS product, but it's very rare to see it on residential these days. But again, it also requires periodic maintenance, cleaning, caulking, minor repairs to keep it maintained. Nothing is maintenance free. Everything requires some level of maintenance. Even vinyl siding, it has to be cleaned, and you still need to make sure things are caulked and sealed properly around openings and things like that. Again, any questions, feel free to throw questions in there. AJ and I will go over, or we'll bring them up at the end to see if there's any questions come up or anything like that. I don't see any. AJ, you don't have to see any questions out there, do you?
We do have one question from Scott. He asked, is there
Okay.
a quick and easy way to identify eaves compared to stucco when doing an inspection?
Once you get familiar with the product, you'll know when you pull up in your vehicle and just get in the driveway, because they do look a little bit different. But another quick way is you can just push on a piece of eaves and you should be able to feel the sponginess, because it's really just styrofoam. You know, the actual finished product is a 1/4 inch or less than a 1/4 inch, and it's like a sponge. Where traditional stucco, it's not. Or you could use. Now I used a screwdriver, because if you use the back of a screwdriver, I don't have one in front of me, but I have a pen, and you tap it. If you're hitting stucco, it's a solid nut. Where the east is going to be more of a hollow sound. You're not going to get that solid knock to it. So the screwdriver trick, is a much easier process. But you just have to you'll have to know the difference between the two products to get a feel or a sound of what each sounds like, and then you kind of go from there. Hopefully that answered it. And so what we'll go is just continuing on. Like I said, if you have any follow-up questions to that, feel free to ask. Hopefully I can explain it differently if need be. Um, but to protect the flashings, we're going to cover a little bit about every one of these. Um, so- excuse me. Roof kick-out flashing is the most critical flashing of all the flashings. And I'm going to explain why. We're going to get into that window, head, door, head flashing, sill and ledge flashing, deck Z flashing, deck, roof, end dams, weep screeds, expansion joints, and chimney flashing. So we got a slide or two on each one of these. So and then oops, sorry. Right. So just types of moisture barrier, or even the moisture barrier itself, it is a layer of flashing that's underneath the finished product. So it needs to be overlapped properly. So when moisture gets behind, it runs down and it always runs over top of the row below it. And then at the bottom, there should be some type of a flashing right down here at the very bottom of any type of the change of material. There should be a type of Z flashing, and the moisture barrier should be over top of that. So everything kind of rolls down, trickles down. But that has certain requirements: 4-inch horizontal seam overlap, 6-inch vertical seam overlap, and a lot of this, it's not visible once the house is finished. So unless you're doing a new construction phase inspection, you're not going to see a lot of this. Um, but the flashings being present or not, over time you'll get to see what these look like. You'll see them. A lot of them are very easily identifiable once you know what you're looking at. And then all penetrations should be caulked and sealed, especially with stucco. But any type of material, they should all be caulked and sealed, because that's a way moisture could access or get behind it. Even the way sliding is overlapped. You have your first piece, top piece overlaps, next piece overlaps. That's the same way everything should really occur. So the kick-out flashing, like I said, is one of the most important flashings. It's one of the most important flashings because it creates the most damage when they're not present. But they're not on every house, and we're going to kind of cover that. But this kick-out flashing is the very first piece of flashing before step flashing starts. Now, I'm going to assume everybody's familiar with what step flashing is. You put a piece of step flashing down, you put a shingle, step flashing shingle, step flashing shingle, and it just steps up any kind of roof to wall line, kind of goes right up the wall there. And then usually they could put the finished product over top of the step flashing, or they might create a cap that goes over top of it and kind of finishes it off, and counter flashing is what they call that. But anyhow, the very first one is called kick-out flashing because any of the water that's running down this roof line, it kicks it out into, because this is usually going to be a gutter here, it kicks it out into the gutter in the direction of the flow to drain gutter. And so these kick-out flashings, they actually have special kick-out flashings specifically designed, and they're required today for stucco houses. But and I have a couple pictures of them, and when you see them, you can't miss them. But anything is better than nothing. It's just an open way where water can just dump behind the material, and especially with stucco, it's the most least forgiving. So, so like typically located where gutters on the roof line terminate at a wall section and direct water into the gutter system. So the average home has 3 primary and 2.5 secondary kickout locations. But they're not typically installed prior to 1995 houses. So houses after 1995, that's about when the kickout flashings came about. Most of them, if they're present prior to 95, they're typically retrofitted. They were put in afterwards, or somebody made something and stuck it in there, and anything is better than nothing. Like I said, missing kickouts is more likely to cause damage to framing wood than any other type of moisture intrusion. And that's why the kickouts are so, critical as well. But here's different locations. These here, these little, I think they call them the Queen Anne Victorian type returns. It's more of a decorative style in the house. They do not require kickout flashings. They're called secondary kickout, and a secondary kickout location is allowed to just be caulked and sealed. But this is a primary. Now in here, it's hard to see, but there's actually a little roof there right below that window that is set in there and has a gutter line. So there's kickout locations there. That's a primary. The other side of this is a primary, and that's a primary. So just kind of identifying different types of kickout locations as to what's required or not. So this next slide actually shows, like I said, is these are what the kickout flashings look like today. They're probably from this to here, it's probably a good 6 to 8 inches. So when you're looking up and you see that, you can't miss it, because it just stands out, it jumps out at you as sort of, but that's all you're going to view. That's all you should view, because everything else could be underneath the roof. Here's your typical step flashings. Everything's underneath the roof or the step flashing or underneath the finished wall, except this piece right here. And then they have a left side and a right side, and it comes in different colors to match whatever. You can either match the roof or match the siding. And a lot of times what will be made is the roofer may take this piece of step flashing and cut it and bend it and make their own kickout flashing. And that is better than not doing anything at all. But it's not this piece of kickout flashing. This kickout flashing is made out of a vinyl type material. It doesn't deteriorate. It'll last forever. So missing kickouts account for about 25% of the high moisture readings, but cause greater than 50% of the total substrate and frame damage. I want to have some pictures of different kickouts as well. Proper installation of pre-engineered kickouts reduce the failure rate to less than 1%. It's very, very important to have kickout flashings. And from my experience, kickout flashing should be required on every type of siding, not just stucco, because vinyl, like I said, vinyl siding is the least forgiving. Stucco is the most, or sorry, vice versa. Stucco is the least forgiving. Vinyl siding is the most forgiving, and everything else fits somewhere between them. So they should all have kickout flashing, because kickout flashing missing on vinyl siding, the wall will rot and deteriorate. It just takes longer for that to occur than it does on a stucco house. But here's a picture. Here's a house that has nothing, and you can see that it has nothing. This is very typical. Here's a house that has a homemade that somebody cut away and chopped away the stuccos. There's a house with nothing. This one, you can see that piece was added, a little piece of metal. I don't even know what that is, but that's better than not having anything at all. This is way better than this. Typically here, this entire wall will be rotted out and deteriorated, even down at the base of that wall. This one has a chance, but if they didn't fix the wall, the damage probably already occurred. And we'll get into that. So, and here's a piece of that kick out that's the proper kick out to use. Like I said, you can't miss it when it's done properly. Um, here's missing kick out flashing. This is some of the damage that can occur. No kick out, and here it is afterwards, nice and clean, nice and cleanly done. Like I said, there's a counter flashing that covers the step flashing that goes up the roof line. Now, the next type of flashing we're going to talk about is head flashing. Head flashing should be in the top of all windows and doors. It should angle away from the house, sort of like this angle here. It can be so slight. It doesn't have to be that, obnoxious of an angle. Very slight angle. So any water just runs off the front of it. Now, what changed over the years? At one time, it was preferred to just bend the edges over and let it run down. Today, they actually run it about a half an inch past the end on either end, and then whatever they do to seal the ends is hidden underneath or behind that piece of head flashing. So even the methods used for flashing have changed significantly as well. But that's head flashing. Again, I'll show some pictures. When it's present, you can't miss it, and it's not present that often in a lot of houses. Um, so here's just another view of different type of head flashing. It can be pre-bent. It can be done on the job site. But you got the head flashing. It should have here some flashing detail around the window. This is like this peel and stick that goes over top of the flanges of windows and so on. Excuse me. And then your siding material goes over top of, now this would be your weather resistant barrier. And then that goes over top of the flanges on the head flashing. This is just showing some detail of some windows. This is I replaced. This is what I did. I had to replace all these, and we were getting some rot down in these corners here because they did not flash around the window as they do today. Again, the house is 25, 26 years old now, and the way everything's done and caulked and sealed has changed over the years. And at one time they did nothing. Imagine a house that they did nothing on. At least my house, they did something. It was just done wrong in comparison to today. Here's just another detail showing this sill pan flashing is probably the most critical because if and when water gets in the corners of these windows, this sill pan flashing will protect it and it will direct that water out and away. And if it's done properly, this sill pan goes over top of the stucco or whatever type of finish material there is. And then these are all this peel and stick flashings that go on. So everything's layered over top of each other. So, oops, that's that one. So on the average, a typical home has 32 windows. And high moisture readings occur about 1 out of every 8 windows. And a lot of it, the windows themselves, like I was saying, they had a lot of problems over that time period when the materials were changing. The whole way the windows were manufactured changed. 60 to 70% of moisture related issues occur at the window openings only because there's so many windows as comparison. Some houses may not have any kick out locations, but if there is a kick out location, the majority of the damage is going to be at a kick out location. So 10 to 20% of the leaks are associated with windows and doors, at the joint between the window and door and the stucco. So that's actually where they come together. So any time you have differing material, stucco wood, stucco vinyl, stucco stone, stucco brick, stucco aluminum, that gap should be caulked and sealed. And they should create they call it kerf cutting, where they actually cut a V into the material so they get a nice thick bead of caulk. If the caulk is put in there and just smeared, it's not going to last very long at all. It's going to crack because the materials, differing materials, expand and contract at different rates. So you get a lot of this going on. And if the caulk isn't a thick enough bead of caulk for it to stretch and move, it just tears it and it creates gaps, and therefore moisture can get in. So again, windows are by far the largest contributor to moisture damage because of how many windows there are on a house as comparison to the kick-out locations. Wooden, vinyl, aluminum clad, double hung windows are the most troublesome. They're also the most common windows. But your solid vinyl windows don't have as many problems because the way they do it today, they have a heat welded seam, so it's sealed real good. Your wood type windows, what happened was they changed the manufacturing process. They put your sill and then your side, your jambs, window jambs sit down on top of it, and they don't seal those corners very well, and that's a problem on some of them. So, and they can be sealed is taking the windows out, taking the all apart, and then they caulk into that miter joint, which is typically in that corner there. Oops, you don't see that picture yet. This is the miter joint here. Now, this looks like a vinyl clad, or it could be an aluminum clad or a vinyl window. And if you see this 45-degree angle, it's usually a hot welded type of vinyl seam. This window here, that's a piece of head flashing that's built into the window. But that's where you'll see the head flashing. Again, having flashing present. Now, it's not ideal, but the way they terminated it at the ends have changed over the years. So whenever this one was built, that's how it was done. And that's so it's proper. It's not proper for today's methods. Here's a curved window. They actually have special material now to create that. You can kind of see that head flashing on the top of that. They also put the head flashing here as well. So you can kind of see that now here. If they just put it here, you still have these vulnerable points at that point and that point. So they put it here, and then ideally you'd like to see if it looks like it's just a decorative type of shutter. So the moisture then kind of comes down and goes behind the shutter and so on. So some other types of flashings, deck flashing accounts, or improper deck flashing accounts for 8 to 10% of moisture problems. Chimneys account for about 4 to 6%. General breaches 1 to 5%, and so on. Here's some deck flashing, a little pictorial. But this deck Z flashing is right here. It's easier to see it from underneath the deck than it is to see it from anywhere else. Sometimes you can see it from the sides, but you really have to get underneath of it, and you'll see this piece right here. That's all. If it's there, that's good. If it's not there, it could be problematic. It depends on how the deck is attached to the house. But if it's stucco, it could be more of an issue, because any moisture could get down in there behind the deck joist, the deck rim joist, and possibly get behind the stucco in that location. Excuse me. Here's another picture of again the deck being attached to the house. Here's that Z flashing here. Whatever the finished material might be, it should still have that piece of flashing, and you can see it from underneath. This next picture actually shows some of it. This one has nothing, and this one has the flashing. So it's kind of just looking for different flashings. Now it depends on, like, sometimes they'll run the cinder block foundation all the way up to here, and that deck beam is attached to the cinder block foundation, which in that case now, or they might just put it over top of whatever the finished material is. This might be frame structure underneath here. So there's a lot of different, just depends on what it is. Here's one that's stucco, and where it could leak without this flashing, water should penetrate where these bolts go through the wall, because you're creating holes. in the stucco material to attach the ledger board here. And so water could get in those locations. So checking underneath here is a critical part of the test from a stucco house. Sill and ledger flashing, anywhere where you have like your sills here, there should be a flashing. A lot of times they just caulk this. If they put mortar there, mortar is the worst thing to put there because it cracks and deteriorates a lot easier. And remember what I told you about the differing materials, though if they expand it cracks at different rates, the mortar cracks, it crumbles, it falls out, then it just creates a gap there. And over time, the sills themselves should angle away from the house, similar to this angle here. A lot of times these sills sit flat and moisture could go back and behind them. So here's a picture of a property that was fixed and done properly. This is one that I actually went and inspected, took these pictures, but you can see the flashing detail here. And then there should be now we're gonna get into this now. That's a weep screed flashing. There should be weep screed here too. We'll talk about that. Oh, that's next. So weep screed flashing, typically located at the bottom of a masonry foundation wall, where the wood framing attached to the foundation. So you have your foundation wall, you have your sill plate, and that's about where the weep screed. And the weep screed is shaped just like that. And then the moisture barrier should go over top of the weep screed and then your wall material. And what that allows is the drainage plane, moisture will come and flow down, and there's usually little holes on the weep screed that allow the moisture to just penetrate and drip through and weep through. But it also allows air to flow up, get behind everything. So not only provides a drainage plane, but it actually provides a little bit of air circulation to dry anything out. Now this is the same picture, but there's weep screed here and there's weep screed down here. Now this is the concrete foundation. These properties are on slab foundation, but wherever you have the actual structural framing should be weep screed also. So that's what that is right there. And then you have it also at a sill. Any kind of sills like that, you should have weep screed. So here's a picture of that weep screed that I was showing you. Like I said, you have your layering, you have your wire mesh, the moisture barrier, your coats of the stucco. It allows the moisture to come down and then it trickles out through these holes. There's actually holes in this piece too. So it allows everything to weep through. So wall penetrations, I talked about this. This applies to all types of material, especially stucco. Again, appliance connections, electrical service lines, light receptacle fixtures, hose bibs, dryer exhaust. I want to speed up because there's a couple slides I want to make sure I get to. But here's just a picture showing some caulk around different products. This caulk, it's a clear caulk that is smeared way too thin. It won't last. And if they say caulk says, if they ever see the lifetime caulk, don't believe it. It doesn't last a lifetime. Especially on the sunny side of the house or the weather side of the house, it doesn't last that long. It should be inspected. Oh, here it is. It should be inspected and maintained yearly, maybe even twice a year. So here's some more wall penetrations. This one, they put the stucco on after they installed the plumbing line faucet hose bib there. But here's another one. Everything should have caulk around it. They should have caulk around it. This should be caulked and sealed, and they're real good. Here's a couple more. That one's got a very bad caulk job, but it's caulked and sealed. And the wall expansion joints, these didn't exist in early, they're not present prior to 1992. And these wall expansion joints should be placed every 140 square foot section of first and any separation of first and second floors should have these expansion joints. The expansion joints minimize the amount of cracking because without these expansion joints, they may get a lot of cracking in this area and this area. There's something that should be on newer houses. You don't, a older house that wasn't built with expansion joints, you don't put expansion joints in after the fact unless you're tearing the entire wall down for other reasons, because they're just too difficult and it could create a lot more problems. So we got just a quick rundown. Windows, not 60 to 70% of moisture related issues, missing kickouts, 25% of high moisture readings, decks 8 to 10, chimneys 4 to 6, wall penetrations 1 to 5. Missing kickouts, like I said, 25%, you're going to have the higher readings, but it creates by far the most damage. So, so part two, I want to make sure I get a few slides in part two. I don't want to keep you much longer. We might run a little bit over, but the inspection testing method. So the method, the industry standards, they have a level 1, a level 2, and a level 3. A level 1, now usually these are all performed simultaneously at the same time. A level 1 is a visual and scanning. Now these scanners they have out there only work on EIFS. They do not work on traditional stucco because the wire lath behind traditional stucco throws the scanners off. Level 2 is an invasive and you're actually drilling holes. We'll talk about that. And level 3 is an exploratory. The method they talk about, if you get into more of this, they say, oh, cut a 6x6 area. Well, as a home inspector or stucco inspector, you're not equipped to fix a 6x6 cutout of the stucco. So what we did, and what I recommend, is you do a core sample, and it's just then it's like maybe a 2-inch core, and I have some pictures of the core samples, but that allows you to see everything behind the stucco, what's going on, what type of materials there are, and so on. And you can always put the core back in the hole, and I have some pictures of that too. We'll show you some of that. Typically performed at the same time. Level 3 not always required. You don't have to do a core, only if you suspect problems or issues and you want to identify stuff. So visual scanning is for EIFS only. You really identify the material type, what risks are. You look for high risk areas, pick out missing flashings and so on. And that's what a level 1 is. I've done some for different insurance companies that they only want a level 1 done. And then when you give them the assessment of level 1, they give approval to go to level 2 and level 3 if needed. So it can be done as a one at a time, but typically they're done all at the same time. Level 2, this is the most common, is you drill 2/4-inch holes, and then you measure mostly at the bottoms of windows and under kick out locations. And you obtain moisture level readings. Here's one. It's the corner of windows. Now this one's already been caulked, so it's very difficult to see because you can buy this caulk in a lot of different colors, and it's also critical if you get into this, buy a good quality caulk. Just don't pick some caulk at your local big box stores or your local hardware stores. Go to a building supply house and get a nice quality caulk. It'll go a long way because you don't want to have to go back because caulk came out or for whatever other reason. The color changed and so on. But here's the holes, and if you look under, that's actually right there. Sorry, I keep talking about the wrong slides. But here's the holes drilled, and here's the holes caulked. Those holes are sitting here and over here. But if you have a good quality matching caulk, you can't see the difference. You can't see them afterwards. So very critical. Again, moisture level readings, acceptable, less than 17, elevated marginal 17 to 22, high defective 22 to 30. Saturated defective is greater than 30. Now that's using that Delmorse type of moisture meter. It has there's two probes on that. You put the probe in the 2 holes, and you're reading the moisture level, you have to bump it because you have to get through the moisture barrier. So you're into the wood some and you're measuring the moisture level into the wood. Now you do the corners where you would have studs, because if the wall sheathing is already rotted out, the depth of the probe will go in further. And that's all part of the assessment, is determining all that. So that's that. We talked about this one. Here's the exploratory that I talked about doing that core sample. So you can drill a hole here. You can see the wire lath. You can see the thickness of the material. That's either the moisture barrier or it's foam board. Here you can see it's being measured and so on. Removing a section. Here's another one that was done. You can see it's like sawdust coming out because it was completely rotted. Here's a piece. Here's looking into the OSB material, taking a picture of it and showing pieces of it falling out. Here's a picture of the actual core sample and so on. This is a picture of that wall scanner that's used. Now you can use a infrared camera. I'm not a big infrared camera fan. I'll be the first one, is because the infrared cameras were designed for hot and cold, and moisture, it can give you the sense of what a cool or cold, not cold, but a cooler location is. But you still have to do the drilling and measuring to verify it. So I just always just did the drilling and measuring. So just real quick, a couple more slides. What's all the fuss about? With stucco. So I'm just going to show you 8 slides, and I'm going to ask a quick question. So again, we have the stucco wall, pretty bad, a lot of deterioration. This next one's even worse. The moisture got in everywhere around this one, on this one. And I don't know why, because I can't see the stucco, what it looked like before that. But this is typical from a window perspective. This is not real typical, but it happens. It could have been too thin and had a lot of cracks. Here's under a window, they completely rotted away. Again, this is typical too. Just showing a lot of different rot. Now this one, the water was probably leaking somewhere up on the roof here, because this is completely gone. There's another one. Like I said, I have a few more, and then I have one quick question, and then we'll wrap it up. But here's one under a door, because the door requires that sill flashing as well. This is under that another door that's a close up. A lot of wood rot. That's actually rotting the sill plate, so that's going to require a good bit of work. This is typical kick-out flashing, missing kick-out flashing. You can see the significance of the damage. Here it is here, and it usually it gets wider as the damage goes down. That's very typical with missing kick-out flashings. And this one's vinyl siding. Like I said, this happens on all types of siding material. Stucco's just worse. Here's a stucco house under windows again, very typical stuff. So here's the question: what is the common component of those 8 slides? And I'll give you the answer, because I don't have a way. I don't see the answers and so on. But anyhow, the common component is OSB, oriented strand board. So it doesn't take moisture at all. So just be aware of it. CYA always have an off-brush stucco inspector perform an evaluation and inspection of stucco houses. Now, stucco, EIFS, and the synthetic stone, it all falls into the same category. Suggest pre-listing inspections another way, or acquires transferable moisture-free warranty. That's with another company. These are just some standards. Oh, actually, I'm at the end, so we'll kind of go for any questions. Send them out. We'll get them answered. If you can send them afterwards. I have my contact information. This is a quote I always like to end it with: quality and service of product is not what you put into it, it's what the client or customer gets out of it. So thanks again for everything. I tried keeping it at or as close to an hour as possible. Helpful links, NACHI, visit NACHI. Great source of a lot of different training classes. And then here's my contact information. In case you need it, you always contact me. Be more than happy to answer any questions or help in any way. So thank you very much, and have a great evening. But